Okay, this week I want to look at if statements. I think I'm going to split this into two videos. Even though the lecture notes cover if statements and switch statements, I'm going to create one video for if statements and then another video for switch statements. Kind of break this up into two chunks. For an if statement, what an if statement allows us to do is, I think the best way to describe this is, think of you walking down a road and you come to a fork in the road where you could turn left or you could turn right. An if statement kind of allows you to do that. So far, all of the code we've looked at so far, it executes from the top down to the bottom. Everything is executed. There's no choice of being able to skip statements, nothing like that. If statements allows us to be able to do that. It allows us to be able to execute some code while not executing other code. So let's look at the syntax for an if statement. If statement looks like this. You start off with the if, and then a space, and then some condition. What's a condition? Remember in the last video, whenever we talked about booleans and conditions, it'll be a condition is something that evaluates to true or to false. So the condition here has to be a Boolean. And then the statements we want to execute go in here. So let's look at an example. I'll copy and paste this into our little online compiler. And then we can play around with it a little bit. Okay, so here we go. I'm going to make this look a little prettier. Something like this. So what happens in this example is we create a constant called num. We set it equal to 10. And then we check here to see if the value of num is equal to 10. So we can substitute, since num is equal to 10, we can substitute 10 in here. So 10 is equal to 10. This is going to evaluate true. And it'll print out num is 10. So let's execute this, see what happens. Okay, let me try it again. We know we run into that problem sometimes. Okay. All right, there we go. Third time's a charm. It says running WebAssembly, so we know that it's going to execute then, and it says num is 10. Now let me change this to something else besides 10 so that this statement here evaluates to false. What happens then is actually nothing gets printed, because what happens is if this is false, we jump over this and we start executing whatever's down below here, which of course in this case is nothing. So let's run this and let's see what happens. WebAssembly and nothing. Okay, so let's do this. Let's say print before if and say print after if. Okay, and so what should happen now is it'll print before if, then right after that, after if. It won't print this statement here. So let's run that, see what happens. Okay, see, yeah. Now if we change this back to 10, what should happen is that we'll print before if, num is 10, after if. So see, from being able to do this if statements allows us then to be able to optionally be able to run certain code. This is actually really powerful. This allows us to do a lot of really neat things. So here's an example. This example, you may want to play around with it a little bit, try a few different things, see what works, what doesn't work. I'll let you kind of explore that a little bit. We could also do something like this, and I'll go through this example. This is not really done that often. Usually if the condition is really small, it doesn't take very long. Notice that this and this is really the same thing. If you've got like a lot of ands and ors in your condition, and it makes it really, really long, you may want to do something like this. So that way you can just say if condition. But most of the time you'll write if statements like this. But I just wanted to show this example so that way you would know that this is a possibility if you need to write it like this. Okay, moving on. To make this a little bit more powerful, an if statement, you can have an if-else statement, and all that you're really doing is tacking on this, and the else, this statement in here gets executed if the condition is false. So this gets executed if the condition, this gets executed if the conditions are true, this gets executed if the conditions are false. So let's look at an example of that. Okay, go over here. Let me go ahead and get rid of all of this. And one thing you'll want to do is try to make your code look a little pretty. The way to do that is to indent the body of your statements, like this statement here. And if you had something else below this, you'd indent it as well. Notice that I indented that. And that just makes it a little easier to read. See, I can tell that this is the statements that execute if this condition is true. And this gets executed if those conditions is not true. So put that here, executed if condition is true, if condition is false, like so. So what's going to happen here? Try to predict what's going to happen. If you got to stop the video, go ahead. Since num is equal to 10, we can substitute 10 in here, and we can say 10 is equal to 10. Okay, that's going to evaluate as true. So we execute this statement, and then we jump over this else statement and then execute whatever's below it. Let's see if that's exactly what happens. Okay, well, here we go. Okay, for some reason, it sees these squirrely brackets not being right. Oh, no, actually, those are right. It's these down here. I'll try to fix that in the notes so you guys don't have to mess with that. Okay, num is 10. Okay, so it doesn't execute this statement. It only executes this first statement. Now let's try another value. Let's say 11. What's going to happen? This here, 11 is not equal to 10, so we jump down here to the else and we execute num is not equal to 10. So let's try that. Let's see if that's exactly what happens. Yep, that's what happens. We can put other statements in here to do extra calculations, whatever we need. Excuse me, but how I'm going to kind of excuse me, how I'm going to represent that is by just putting an after if, so that way you know that these statements get executed. So let's try running this again. You notice before if, then we only execute this print statement num is not 10 because num is not equal to 10. Then we do the after if we change this back to a 10, or even better, let's try something else. Let's say if num is greater than 10, or you could also do greater than or equal to. This is not a statement that I showed you in the conditionals, but you could write it this way, greater than or equal this way. So 11 is greater than or equal to 10, so this is a true statement, so this gets executed. Let's run this just to make sure that we are interpreting that right. Yep, that's true. Num is greater than 10. Let's change num to something that is not greater than 10, let's say 5. We can execute it. And we notice here num is not equal to 5. So this gives us even a little more flexibility. Remember what I was talking about at the beginning whenever I said an if statement is kind of like a fork in the road. You can go left or you can go right. Actually, it's the if-else statement that allows you to go left or go right, because you execute this if the condition is true, you execute this if the condition is false. All right. We can create even more complex if statements if we want. We could say if condition, and then we execute this if this condition is true. Else, if condition 2 is true, we execute this statement. Else, if condition blah is true, we execute the next statement. Now we only execute one statement. We don't execute if condition in condition 2 is true, both of them are true, we only execute the first one that we run into. After that, remember what the else does. It only does these other statements if this condition is false. Okay, the best way to really look at this is to look at an example. Let's continue by copy and paste this example, and then we can make adjustments to it if we want to. All right. Okay. So here we've got really the same example that we've been looking at. Let me make it look a little prettier. You should really try to write your code so it looks similar to what I've got here with this indented, because it makes it a little bit easier to see. Where these bodies of the statements are and where the else statements are, the else if and else statement. So let's look at this. Let's try to figure out what goes on here. If num is less than 10, it'll print num is less than 10. If num is equal to 10, we print num is 10, and then else it'll print for all other conditions. All these other conditions here are false, which means that num is greater than 10. It has to be greater than 10 because this takes care of if the num is less than 10, if num is equal to 10. So the only possibilities that are left over is if num is greater than 10. So using num equal to 10, what's going to get printed? Well, we know 10 is not less than 10, so this is false. So we jump down here. Else, if num is equal to 10, 10 is equal to 10, so this gets printed, and then we jump over this else down here. So what I'm going to do is I'm going to put in like what I did for the other examples, after if, just so it makes it clear that we are looking at the code before and after, like so. So let's run this, and what it should print is before if num is 10, after if. Okay, there we go. So let's change this to something else. To get this first one here to execute, it needs to be less than 10. So let's say 5, and let's run it. What's going to happen? Well, let's execute the code and let's find out. If num is less than 10, it's going to print out, and that's true, 5 is less than 10, so it's going to print out num is less than 10, and then it's going to jump completely out of the if statement here because there's no need to execute the rest of this. So it's going to jump down here and print out the after if. So let's run this and let's see what happens. Okay, that's exactly what happens. You see how I'm trying to go through and mentally look at the code and trying to figure out what it does. For you to be able to write code, you've got to be able to read code first. And so that's what you're going to have to learn how to do. If you can learn how to read it, then you can write it a little later. You remember back, at least whenever I was in school, we learned to read before we learned to write. And with coding, I think it's exactly the same way. It's a little bit easier to read than it is to actually write code yourself. So look at these examples, try to predict how they're going to execute before you click the run button. Whenever you go through and make a change, try to predict what it's going to do. And if you get it wrong, if you predict it wrong, that's okay. Go back and look at the code and try to figure out where you went wrong. It happens to me all the time. As you can probably see in some of these videos, I will predict that something's going to happen or that it's going to run, and then I get an error message, and then I got to go in, try to figure out where it's at, fix it, and then try to run it again. And that's where debugging comes in at, is that you wrote code, it actually executes a little differently than what you expect it to, and you have to just take the time to go in and try to figure out how you wrote it incorrectly, and then make those fixes, changes, and go from there. So let's try, we've tried 10, we've tried 5, let's try something greater than 10, because what I'd like to do is to try to get this down here to execute. So let's say 20. So let's run through our if statement. If num is equal to 20, if 20 is less than 10, we know that that's false. We jump down here. Else if num is equal to 10, we know that num is equal to 20, so that's false. So then we jump down here to the else and we print out this statement. Okay, so what it should do then is print out before if, all other conditions were false, so number is greater than 10, and then it prints out after if. Let's see if that's what it does. Okay, that's exactly what it does. Now let me do something else. I want to try to change this so this says else if num is less than, let's say 9. And let me put 5 up here. Now I've stated this a couple times, but I really want to stress this again. Notice that this condition is true. 5 is less than 10, but so is this condition. So what's going to happen? Is it going to print out both of these? Is it going to execute this and then execute this? It shouldn't. What it should do is for the first one that it comes to that's true, it executes that one and then it jumps down and prints the after if. So what should happen is before if, num is less than 10, and then after if. Even though this condition is still true, it does not get executed. It does not, that check does not happen. It just jumps down after this statement here, it jumps down here. So let's look at this. Let's see what happens. Okay, num is less than 10, so it executes this first one. Notice that it ignores everything else here. It just jumps down here and prints after if. Something else that I want to point out is so far all of our examples only have one statement in the if statement. You can have other statements in here too. Let's see equal num plus 1, and then you could print out print C is equal to C. Notice that I wrote it this way, and then what this will do is this allows Swift to look at this and notice that it needs to figure out what the value of C is. It takes the value of C that's up here and places it there. So what happens here? Whenever we try to execute this code with num equal to 5, it'll look here and it'll say num is less than 10, so 5 is less than 10, so it's going to print out this statement. It will then execute this statement and then execute this statement. And once it's done, it'll jump down here and print the if statement. So let's run this and let's see if that's what happens. Okay, that's exactly what happens. C is equal to 6. Now, as you go through here and you start making changes to things to see what works and what doesn't work, you know, I've been coding for almost 30 years. Well, I have been coding for 30 years. So this, in a way, comes a little natural to me. I can look at code and usually can kind of figure out what it does, at least with some of the basic stuff. You may not, you may predict wrong what's going to happen. You may predict that that something else happens. If that happens, that's okay. It just takes a lot of practice. Realize that it's going to take some time to learn. If you got to go back and watch a video again or look at different examples, take examples from the book, or if you have to do a Google search on Swift if statements and watch another video, or read some extra code, or read some extra documentation, feel free to do that. You can do that with anything that we cover here. I'm just giving you a basic overview of the material. And if you understand what's going on, you're able to go through here and make changes, and things make sense to you, that's great. But it's going to take practice. It's going to take you going through and messing around with the code a little bit till you understand what goes on. So getting back to what I was trying to get at before, was that you can have multiple statements in here. You can have tons of statements in here. You could actually have other if statements. If C is greater than 5, you can also have other print statements, as I just wrote, or you can have other if statements like what I got here. So your code can get pretty complex. So what's going to happen here? With num equal to 5, this is going to evaluate true, so it's going to print out this. It's going to set C equal to num plus 1, which num is 5, so C is equal to 6. Since C is equal to 6, this statement is true, and so this is going to get printed. So I'm going to run this. See what happens. Okay, that's exactly what happens, is what I predicted. So notice here what I did. Play around with different things. See what works, see what doesn't work. Change the value of num here to different values. Add different stuff in here. Change your conditions. Do what you need to do for that. Maybe, remember what we talked about last video, or in the conditional and Boolean video, we had the and or operators. So you could put stuff in here if you wanted to. Like for example, let's say that we only want this to get printed out. We know that this is only going to be done if num is less than 10. But let's say that and num is less than 5. What's going to happen? Well, num is equal to 5. This is true, so this gets printed. C is still equal to 6, so this gets printed. If C is greater than 5, well, this is true, so what I'm going to do is write down this is true, and num is less than 5. Well, num is 5, so this is false. So remember our truth tables, we got true and false. This is going to evaluate to false. So this doesn't get printed. Let's see if that's true. Let me see if I'm right with my logic. I might be wrong. As things get more complicated, it's easier to start making mistakes. Well, it didn't print out C is greater than 5, so this statement is evaluates to false, like what I said here, and that's so it doesn't get printed. So notice that these three get executed. This gets evaluated to false, so then it jumps here, which it doesn't need to do any of this, and it jumps to here. Okay, let's move on. We'll look at some of these examples here. Actually, I've already kind of done a little bit of this in the last example, but that's okay. Let's look at a simpler example, just in case that's a little bit too much to chew in one setting. Let's look at this example, and let's make it a little prettier so it's easier to read. Put a block, an empty line there, so we separate our where we're setting up our variables versus the if statement, just to make it look a little prettier. So let's see what's going to happen here. And what I'm going to do to help out a little bit is I'm going to put the true and false above these, just to make it a little easier to try to remember. So num is equal to 10. This is true. And string is equal to high. That's equal to true. And we know with the AND operator, both operands have to be true for the result to be true. So this is going to print out num is 10 and string is high. So let's see if I predicted that right. Let's run this. Okay. Now let's do something else. Let me show you that this string with a space in there is not equal to this. Num is still equal to 10, but this is going to be false. Notice that there's a space in here. And there's no space there. So this is going to evaluate false. And if we do that, nothing should get printed, and it doesn't. So notice that. See what's going on. Realize that that's what's happening here. Is that this is getting evaluated. It evaluates false. We don't do this. What happens if we change this to an OR? Pause the video if you need to. Go look at the notes for the conditionals if you need to review what the OR statement is. What happens here? Well, looking at the OR statement, we've got to have one or the other of the operands being true for the result to equal true. So whenever that happens, this evaluates to true, and this will print the statement here. And what I'm going to do is I'm going to change that to an OR so that the print statement is somewhat accurate. Let's compile it. Let's run it. See what happens. Okay, num is 10 or string is high. Of course, we could have left this as an AND because it doesn't matter. The print statement, the compiler doesn't care what's in here. It'll just print it, even if it's a false statement. Notice that this is a false statement. Num is 10 and string is high. That's a false statement, but it doesn't matter. The print statement will print out whatever. Whatever you put in here. So I could put something in here. Billy is silly, and it'll still print it. It doesn't matter. Of course, Billy's silly is probably a true statement. You get the idea. So play around with this a little bit. Change the value of num. Change the value of string. Change this to greater than. Change it to, of course, the string here. If you do that to a greater than, it's not going to know what that means, and it's probably going to give you an error. So let's click on run. Let's see what happens. Oh, well, since this, okay. See? I didn't really know for sure what was going to happen. It printed this, and I know why once it happened. Remember how we talked about the short evaluation, the shortcut evaluation stuff that we talked about last time? Since this is true, this doesn't have to even be evaluated. So the compiler could have looked at this and complained about it, not knowing how to compare strings. So see, even the instructor sometimes makes silly mistakes. So that's why you got to run things and kind of see what happens. I would have guessed this would have produced an error if I had to make a guess. And I was wrong. It actually runs just fine. But realize that if you do things like this where you're comparing a string to another and assuming one's going to be greater than the other, how does your language, how does the compiler deal with that? Different languages are different. Some are going to give you an error on this and say it doesn't know how to do that comparison, and other languages aren't going to do that. But since this evaluates just fine, let's see what happens. And I have no idea what's going to happen. If we just do this, let's eliminate that first statement. So that way we don't even have an or an and, nothing like that. And we're just going to see what happens here. Is this going to give us an error, or will it complain somehow, or will it just run it and say that it's true or false? Let's see what happens. Hey, Okay, for some reason, it knows how to compare strings. So that's something I'm going to have to look at a little bit more. I'm not real surprised that it ran okay because it didn't give us any kind of compile error or anything like that, or say, hey, I don't know how to do this. So that kind of told me that it probably was going to run okay. I just didn't know if it would produce that as a true or a false statement. So there you go. That's something that kind of surprises me. A lot of the other stuff really didn't, but that kind of does. Here's one that does the short circuit evaluation. Let's look at it a little bit. Let me make it look a little prettier so it's a little easier to see and read. Let me change that to a lowercase so that way really I don't think it should be an uppercase I for the if. So let's evaluate this. Let me see, with the X, we were not really evaluating, or we don't have a value for X. So let's define X. Let's say X, let's say let X equal to 10, or let's say 20. So what happens here? Or let's say this is 25, because since we already got 20 in the example, I don't want to confuse things. So let's evaluate this. 10 is greater than 20. That's false. Since this is an AND for the short circuit, we know that it doesn't matter what this is. It's going to always evaluate to a false. So is X less than 10? That's false as well because X is equal to 25. So this statement, this will never get printed. I need to change this to the correct using the double quotes. I'll try to change that in the notes for you so that way you don't have to change it. And so it should just come back with nothing. Yeah. And part of the reason for that, well, false and false is going to evaluate to false. Let's change this so that this is actually equal to true. X is less than 10. One value that we know that's less than 10 is the value of 5. So in this example, this is true. So we have false and true. Run it. We still get the same thing. It doesn't matter because whatever we do here, it's going to always evaluate to false. It doesn't matter what the second one is. This would just never get printed because this will always evaluate to false. It doesn't matter what you do. So technically, this code never gets executed, never ever will. So it's silly to have that example there. And it's possible to do this. I see it in code from time to time. People will write something silly to where this statement is always false at the beginning. Now, it may not be as blatant as you see here where the values are hard-coded in, but as you evaluate it, you notice that this always will evaluate to false, and you have an and this will always this will never get executed. So that does happen from time to time. The OR operator, an example of that real quick. I know this video is starting to get long, so I won't want to spend a lot of time on this. But let's look at this, and we may create some actually in the example here. That won't compile. I actually left off a double quote at the end there. If num is equal to 10 and string is equal to high, we've done a lot of let's do a var because we can change the value of num. Let's say var string equal to high. Let's write it that way. So technically this string is not equal to that one because this one has an uppercase H. This has a lowercase h. So let's see how this is going to evaluate. Num is equal to 10. That's true. And so in this case, it doesn't matter how the second one gets what the second operand evaluates true, because this is always going to be true. For the OR, you only need one of your operands to be true for it to evaluate true. If both of them are true, it also evaluates true. So this is going to get printed. Yeah, num is 10 or string is high. Notice that string is not equal to high or uppercase H I. Let's change this so that this is equal to something besides 10. So this is going to evaluate false. The second one is also going to evaluate false, which makes this false. So nothing should get printed. Okay. So I'll let you play around with this, stop the video, try a few different things, try some different examples, and then we'll talk about our last topic. Remember in the other video I talked about string is empty. You can try a few of those examples if you want. I'm just going to skip over that. One thing that we can do is sometimes we can create a shortcut. For example, here we can have a condition. If it evaluates to true, we have this value that's returned. It's a shortcut for an if statement. Think of it as like a shorthand for an if statement. We have a false value. So let's look at an example here. And then I'll show you using the if statement, and then I'll show you using the trinary operator. Okay, so let's go back. Okay, we've got two variables, A and B, one set equal to 10, the other one set equal to 5. And then we create a variable called min, set equal to int. And I think this needs to be, well, I think this will work. Let's see if this works with it being a let and let it be set like this. Once we set it, then we may not be able to update it. Let's see if this actually runs. I'm going to leave the if statement this way, and there's a reason for it. You could go ahead and move this down like what we had before, like this if you want, but I'm leaving it this way for a reason, and you'll see here in a minute. So let's execute this. Let's see if it even runs correctly. Oh, we don't have a print statement. So say min and max. Now let's run it and see. Okay, so out of those two values, it's going to set min equal to the smaller one and max to the larger one. It actually does that, 5 and 10. Min is the minimum number, 10 is the maximum number. So there you go. With the trinary operator, we can do exactly the same thing. What you do is you would, instead of writing this, you write A less than B, and then let me go back here. Yeah, to see exactly the syntax for it. Yeah, you could write it just like this. So actually you can get rid of this. When you set let min equal to A less than B, notice that's what's here. That goes here before the question mark. Then you put A here, because that's true. If this is true, where A is less than B, A, we want that to return and be put in min. And we put our colon and then B. Notice it's roughly what we're doing here. Min is equal to A, min is equal to B. And so it knows to let this equal to the minimum of those. So for the maximum, it's roughly the same thing. Let max equal A greater than B. Is the conditional, like what we got there. A greater than B, and you have your question mark, because you put the conditional before the question mark, then you put the value that's returned when this is true. So we have A and then B. Because notice here, max is equal to A, so we put A there. Max is equal to B, we put B there. So if we run this, we should get the same thing as we got here. Okay. Now, to be honest with you, I really don't care which syntax you use. Usually this is used for some basic simple examples, like for example, min and max that we've got here. It never hurts to write it this way. And so if you always write it this way, that's fine. Just realize that if you're ever looking at code and you see it written like this, you know what it means. On a test, it may be written like this. You may need to figure out what it means. But if you never want to write it like this, that's fine. I very seldom ever write code like this. I almost always write it like this because I think that it's easier to read. And so I just wanted to introduce that concept to you. So I think that's it for this video. I will create another video about switch statements and we'll post those, but I think this video is long enough. Feel free to go back and rewatch anything that you need to rewatch, or to stop it and try some different examples, whatever. That's going to be the best way for you to learn how to code. And so good luck. Ask me any questions that you may have.